what is it, Desert Sun Stadium?
Yeah.
Over by the Civic Center? I highly recommend that after this field trip. Or Golden Corral, your choice.
Wish the Tamale Festival was sometime.
Exactly. It'd be fantastic. Alright folks, so while the rest of the people are coming in, we are here to look at the Hilltop Diabase, which is the greenish material up there. And when I said we're coming up here because we have to get a piece of it, technically I wasn't lying. The good news is though, it's at your feet. So everybody look at your feet and pick up a greenish tinted rock. If you have a greenish tinted rock, that is probably it, but you can check with your neighbor. Everybody pick one up because we're going to need to look at them and identify some things. Very nice, very nice. Yes, show your neighbors if it's green as theirs, you got the right stuff.
Hey, T-Bro.
Okay. All right. So, the first question we need to address with this is it's asking us for the texture of the rock. Now, the rock's texture is, did Miguel make it up? Where's Miguel?
No.
Oh, he's hanging down there? Oh, okay, all right, that's fine, thank you. All right, so, just wanted to make sure he wasn't abandoned. Okay, so, the first question, page 1, pretty much number 1, is it wants to know the texture of these rocks. Now, the texture of these rocks, for my classes, I do texture a little differently than the other professors might. For me, coarse-grained is anything you can see. Even if it's very small, if you can still make out the shape of a mineral or the crystal shape and whatnot, some features from the crystal, you can still see that mineral. So coarse-grained is anything you can see, even if it's really small. Fine-grained, on the other hand, is you're only going to see with a microscope. The most you'll get out of it is perhaps the color. And then porphyritic would be a combination of both, but we'll see if we need to use that one. So right now I want everybody to look, and I want you to tell me if you're looking at coarse-grained or if you're looking at fine-grained.
Coarse-grained.
I heard somebody say fine, though. Does anybody else say fine? No. Okay, we have one. Kim's honest. She's like, yeah, I got it. Here's the deal. Every one of you is correct, coarse or fine. Check off whichever one applies to your rock. I'll explain why both are correct in a minute. If you have coarse, check off coarse. If you were reserved and didn't want to say fine just because everybody was saying coarse, check off whatever you truly have. It's not wrong.
I said fine.
Okay? Coarse or fine. I'll explain that in a minute. The next question it wants us to know for number 2 is bringing us back to why we studied minerals. What minerals, looking at the rock carefully, what minerals do you see in the rock, or what minerals do you think could be in there?
Yes, all of them.
All of them? Oh, I thought you said all of them. She said all of it. Like, yeah. Olivine is definitely going to be one. Olivine is what color?
Green.
Olivine is olive green.
Just said all of them.
Yeah.
Olivine sounds better.
Olivine is olive green. And so that is certainly, based on the green color, even if you're dealing with fine grain, you can tell there's olivine in it. Now the next one is a little bit complicated. I'll give you a hint in that it's a mineral that forms in Bowen's reaction series discontinuous phase directly after olivine, okay? And it begins with a P. What mineral is that? It's not plagioclase. That forms in the continuous series.
Pilot.
It's not pyrite. It does begin. PY is correct.
Pegmite.
Okay, I'll give you all help because I know we just got back from spring break. Pyroxene. Pyroxene.
Yeah.
P-Y-R.
I was about to say it.
Yeah. Yes. P-Y-R-O-X-E-N-E. Pyroxene. And the reason I'm helping you out with that is pyroxene is a difficult one because depending on its chemistry, it can either be green in color or it can be black in color. Also, on top of that, in my class at least, we didn't have a hand sample of pyroxene. So it can be green or black, but based on what you're seeing here, what color do you think the pyroxenes in this are? Green. Yeah, they're going to be the green ones. Now the other thing, looking closely at your rock, you'll notice there's also some minerals that are not green in color. Specifically, one that is white. Now before you guess on this, let me give you these hints going back to our mineral examinations. The mineral that's white in these rocks, if we had it in class, first off, it would have been a lot bigger. Secondly, it would have blocky cleavage, it would have a hardness greater than 6, so it would scratch the glass plate or the streak plate. It has striations on it. And there were two different types you looked at in class. One was white, one was pink. Not quartz. Good. Feldspar, yes.
That's what I
Plagioclase
said.
feldspar is correct. Orthoclase or potassium feldspar was the pink. We're looking at the white one, which is plagioclase. Okay? And that makes some more sense because plagioclase is usually found with more mafic minerals like our pyroxene and olivine based on Bowen's reaction series.
Bless you.
Oh, you said blessed for the rest of the day.
Oh, it's the same girl.
All right, number 3. Number 3 gets technical. Number 3 gets technical. Number 3 is, I know in my class I didn't have hand samples of it, but it might be something you've only heard once or twice in class, most recently on the Telegraph Pass field trip. Okay? So, it begins with a D. Does anybody remember the word? It's not diorite, it's close. Diabase, somebody said. Diabase. D-I-A-B-A-S-E. Diabase. Okay? Now,
Name, right?
say again?
Rock name?
Yeah, that's the rock name is diabase. Now, here's the deal. Does anybody know what diabase is? Okay, let me help you out. When I was in your position as an undergrad, I went to a geologic dictionary, and it gave me the worst definition for diabase ever. Then I tried the almighty Google way back when it was in its inception, and it still gave me a horrible definition. So with this, what we're going to do for diabase is we're going to say that diabase is a shallow lava, pretty much, a shallow volcanic eruption. And what that means is that it exhibits properties of both fine and coarse grain, or in other words, some of the diabase looks like it could be gabbro, which is coarse grain. Others looks like it could be basalt, which is fine grain. So that's why earlier, everybody was correct. It could be depending on where you look at it. It's not both at the same time, but depending on where you look at it, it exhibits features of coarse and fine grain.
Which one was the fine grain you said?
Fine grain was basalt, coarse grain was gabbro, but the rock itself is diabase. It has properties of both of those. Moving on. Now what it wants us to do is it wants us to look at the mountainscape here. And it's going to ask us a couple of questions for number 4. And number 4, it's asking us, first off, do we see any other features of note? First one is jointing. Jointing is vertical fracture within rock. Does anybody see that anywhere? Not even just in the diabase, but anywhere on the mountainscape. Okay? If you do see it, you can check that off or circle it. Actually, I think circling it's easy enough. Just circle it if you do see it. If you don't see it, put a neat line through it. If you don't see it, you don't see it. And it all depends where you look. If you're looking at one part, most of this is not jointed, but there are a few sections that are. Next is mineralization. What that means are there fractures in which minerals have grown. Minerals around here are mainly going to be quartz infilling cracks, which you may have seen, or if we're really lucky, things like gold infilling minerals. Do we see any kind of minerals filling in cracks?
Yes.
Okay. If you do see some, you can check it off. If you don't, the majority of the minerals have weathered out here. So it all depends on your interpretation and where you're viewing it. Next is weathering. And with weathering, I'm also going to tack on the term erosion. Okay. Looking at the whole mountainside here, do we see weathering and erosion?
Yes.
Absolutely. Who can give me one example of a location where we see weathering and erosion?
Bam.
Yeah, exactly. The best idea here is that the diabase wouldn't even be visible to us if we didn't have the scoop-shaped indentation weather away and erode away. So right there, another example, up top, you can see the metamorphic rock. Even though it's resistant, you see lots of chunks breaking off. And that's going to be some more examples of weathering and erosion. So it's all over. The stuff we're standing on right now only got here because of weathering and erosion. Now, number 5, I do not like how it's worded, so I'm going to reword it for you. Basically, number 5 is asking you folks to look at the mountainscape again, specifically with respect to the Adair Formation, the sedimentary rocks that you looked at earlier. With respect to the sedimentary rocks you looked at earlier, how are they contacting the green diabase material? And it gives us 3 possible options. Now, this is kind of like an SAT or ACT question. Which is the best answer? Sometimes more than one can apply, but which is the best answer? The first one is going to be faulted. And with faulted, it means there's a fracture along which movement has occurred. So does anybody see any type of displacement, misalignment anywhere on the mountainside?
No.
Okay, some people are shaking their head no, and I would agree. The next one is unconformable. Unconformable means materials were deposited there, then a large section of erosion removed a great deal of materials and a lot of geologic age away from the mountainside and deposited much younger materials. Now, we don't have any ages, but I can tell you that unconformable is not really going to be that big of an issue here. There are some age differences, but in an unconformity sense, not so much. So that leaves the last one is intrusive. Is it an intrusion? No. And I will tell you this. You cannot see it here, but if we hiked over the mountain, you probably saw it from other stops, there's a lone tree on the mountainside. If you walk 20 feet behind that tree, there's going to be an exploration tunnel where they dug into the mountainside looking for gold long ago, unsuccessfully. At the end of that tunnel is this diabase material again. So what that tells us is this diabase material is actually in the mountain, going diagonally up. If we cut the mountain in half, we would see the diabase run through diagonally at 60 degrees. At a 60-degree angle, discordantly running through the mountain. Okay? Now, the intrusive part, if we get with the intrusive part, the intrusive would mean that the diabase would have had to, as a magma, burn its way through any other pre-existing material that was there. Is that a possibility?
Yes.
Why? Because one of the things it's going to ask is, I think, state your evidence. Why is intrusive a possibility?
Because it's intrusive. It's just a layer. It's not the whole thing. So it's,
You're somewhat. I want you to word it different.
It cut through the mountain that was already there.
Exactly right. And more specifically, how did it cut through? Did it go straight in line with the layers that were there, or did it go at a different angle?
Diagonal. Yeah,
it cross-cut. Cross-cutting is the technical word. You're absolutely right. Cross-cut through. Okay? And in geology, we have laws or principles of geology. That would be the principle of cross-cutting relationships. The material doing the cross-cutting is always going to be younger than the material that it moves through. And in this case, the diabase was a scorching hot magma that ate its way through anything that was in its way and left this weird 60-degree diagonal shape. If the other material wasn't there in the first place, it'd be very awkward to have a 60-degree frozen lava flow. All right, so that's our evidence there. It's basically the principle of cross-cutting relationships helps us. Principle of cross-cutting relationships helps us to determine that. And the angle, too. Next, it asks number 6, again reworded. Number 6 is asking, now let's look at the top. What's the contact like between the diabase and the metamorphic rock up top? Looking at that, the first option is faulted. Again, is there fracture with misalignment of any type? No. Okay. To be fair, though, I will say there is faulting in the region, because you folks just saw that metamorphic rock down there, and over here it's at the top of the mountain. How does it change in elevation? There's got to be faulting somewhere, but that's probably not what's doing it here. Depositional. What does deposition mean?
Materials were deposited.
Well, don't use the word deposit to define depositional. What does it mean? In place. Very good. In place. Stuff was in place here, usually by wind or water. With respect, yeah, transported, in place, wind or water. Would a metamorphic rock or an igneous rock be placed by wind or water?
No.
Not really. That would be something to see if it happened. And lastly, is it, again, intrusive? Is it possible the diabase burnt its way through the metamorphic material and just incinerated it? Is it possible?
Possible.
Exactly. So that's going to be our answer. Okay? So that is our number 6, and I think that's the last one for us here? Okay, so what we're going to do, first off, are there any other questions or anything somebody wants me to go over so we're clear, or has everybody pretty much got it?